everybody, this is Derek Goodwin from P9 Cam Solutions. Welcome to our Friday Lunch and Learn series. Today we are going to do the introduction to Inventor HSM. Tim Paul from Autodesk is our presenter today.
Hi everybody, thanks for inviting me, Derek. I always like to participate in these when I have time. So my understanding is this was a kind of an intro Inventor HSM webinar. So I usually recommend people start their first parts with some more simple parts, kind of figure out the workflow. So I thought this was a good part. It's definitely not a super simple part, but it's also not a super advanced part. So it has some features. It could be, we're going to show you how to do this in a 2 operations. We're going to machine these little feet here with some 3D toolpaths, and instead of having to flip it up on its side to machine these with the side tool, we're gonna work through machining them with a 3D toolpath. So with that said, I'll get right into it. So during this, I'm going to show you how to utilize some templates, but after I use the template, we'll kind of go backwards and show you how we got through the template. So first thing I'm going to do here is go to Setup. We'll start with the creation of the setup. So what I like to do is in these tabs, I start with the model. First thing I do is select my model, and then the next thing I do is set my orientation of my work coordinate. And I generally start with select Z-axis plane, and I'll just grab a top surface there. Next thing I would do is make sure it says stock box point. And this part, what I want to do is set my work coordinate point to the lower left corner, so it's going to be sitting on the parallels against the hard jaw and against my stop on the left side. And my X is pointing in the wrong direction, so your XYZ always wants to be pointing in the positive direction. So we'll flip the X, and we could just hit OK. But we want to set up our stock. So I like how Inventor sets this up where it usually defaults to a fixed size box, and then it puts in the values of the minimum size that you need. I usually write these down on a post-it, and then I'll walk out to my shop to see what the next bigger piece is that I have. So let's assume for today we have a 6-inch by 4-inch bar stock. Or let's say, 4 by like 1.5-inch bar stock, and we're going to cut it to 6 inches long. And then I want to hold on to the bottom with, let's say, some Mighty Bite Talon, little vice jaws. So I'm going to offset it to the negative direction by 100 thousandths. You know, those Talons need about 65, 70 thousandths to hold on to. In the post-process tab, this is where you would name the program number, and I'm going to put in first op for the first operation. So that's just a comment that's going to put out. And then I'm going to leave my work coordinate system output to 0. So 0 and 1 equals G54, like on a Haas machine. 2 is going to be 55, and so on and so on. So right now we're ready to start adding toolpaths. So you can see the representation of the stock and then the model. So always remember that our software's, the intelligence of our software is to look at what you want when you're all done and then try to remove the stock that you define. So we define the stock and then define the model, and then hopefully all we end up with at the end of the day is the model. So to kind of talk through the setup or the operations, generally I'm going to start with making a face operation on this, and then with this part, normally I would go in and rough it after that, but with this part I want to drill these holes so the location is good before I rough out this, so I'm not drilling on an angle. So I'm going to face it. I think I'm going to drill these holes, and then we'll kind of just start attacking it from there. Quick little disclaimers, I haven't spent much time on prep on this, so you might get to experience me working through the part as we would in the shop. So sorry if we get hung up on anything. So the first thing I'm going to do, I like to use my right-click selections in this gray space. I think it's a little more efficient than coming up and grabbing it out of your ribbon up here. So I'm going to go New Operation, 2D Milling, and then Face Mill. And then we have our 5 tabs here. I'm going to go to Tools. I'm going to go through my tools and grab this Face Mill. So hopefully I should be able to hit OK. Nothing blows up on us and we get a toolpath we like. So there we go. So we got a roughing pass, actually 2 roughing passes and a finish pass, which is exactly what I wanted. So if your facing operation, your default facing operation doesn't look like that, you can go into these tabs, your heights tab, your passes tab, and you can set all these things, and we'll kind of walk through that in a little bit, but you can set all these. You know, an example would be your step over. You can go edit that expression and set it to 45% of the tool diameter. So you set all these things up the way you want them, and then if it's the type of operation you're going to do most in your shop, then you just right-click on it and make that your default. So the next time you go to face something, it's going to face it like you set your defaults. Quick note on templates: if good use of a template is if most of what you do is face aluminum, maybe set up all your defaults to be set up for that. And then if you want to set up a special template for cutting steel, you just go edit all those and then store something as your template. So Derek, I think I participated on a webinar with Derek earlier. I think he listed it as like productivity tools or something like that, and it's on his YouTube channel. So if you want to learn more about any of the default setting, template setting, my sweet spot and what I care a lot about is helping people program more efficiently. So check that webinar that we did out if you need to know more about setting defaults and templates. But I'm going to use them as we walk through this part. I'll try to kind of lightly touch on them. So we have a facing operation, and now I want to drill these holes. So I'm going to right-click and go New Operation, then Drilling, and then go back into our tools. And I already looked to see what size those holes were, and they're 375. So I'll click on that, and then we don't have to go to the Geometry tab. We can just grab the Geometry right out of here, or I'm sorry, right out of here, and then it'll jump to the Geometry tab. So instead of having to click around all the holes, we could check this box here where it says Select Same Diameter, and that'll run around and grab all the other ones with the same diameter. So something important to notice is it's rapiding down to here, and then it's going to start drilling, because the default for the heights is that the top, which is where the cut starts, is set to the top of the hole. So we want to change that to be the model top. So now it's going to start drilling at the top of the model because we already faced it down to that surface. The other thing I want to do is I do want to turn on this drill tip through bottom. So it's going to take the drill angle and the drill tip into consideration, so you have a full diameter in that hole. And I also want to drill past that by 30 thousandths of an inch. Going to the Cycles tab, I really like this chip breaking cycle. So it'll take take small pecks, but only partially retracting to break the chip, and it'll keep going in. And this accumulated peck depth is it's an awesome tool too. So if you look at the expression, it'll take small pecks until it gets to 2.5 times the diameter of the tool, and then it pulls out, removes them all, goes back in. So there we have our drilling operation, and you can see, like I was saying before, you're not rapiding down here, it starts up there. So now I want to rough the part. So I like to use our 3D adaptive as often as possible. So a lot of people look at this part and not really think it's a 3D part or a part similar to this, but pretty much everything we make is three-dimensional. So it's going to take it and look at it as how it can route the entire part with one tool. So turn on this adaptive, go back into the tools, and I want to find this half-inch tool right here I think will work. So we shouldn't have to make any geometry selections. I do want to make sure that I cut past the bottom. So I'm going to say like 20 thousandths past the bottom. So I'll type in negative 20 thousandths from the model bottom. I want to make sure the top of the cut starts at the model top. So it's already set up that way. Looking at the passes tab, I shouldn't have to change anything. So I'm going to hit OK. If I don't like something, we can always go back in there and edit it. So at this point, before I get too far, am I running ahead of anybody, or does anybody have any questions? Okay. Well, I'll keep talking until somebody stops me. So right now, calculated that adaptive toolpath. So if you can see, it looks inside and outside the part. And it helixed all the way to that bore. It roughed all these open pockets, and it even made these step-down passes on this on these feet, or these little angled area here. So now we can go in later with a ball mill and get that in one setup instead of having to turn it up on its side and side mill it. So sorry I didn't do any more prep on this. I just want to kind of think through the part as I would be doing it in the shop. So right now I would probably simulate it, kind of get a feel for where I'm at. Always when you're simulating, I turn off toolpaths, turn on stock, and then most of what I care about is making sure my tool's not colliding with anything. So I turn on stop on collisions. You know, maybe we picked a tool that didn't have a long enough flute and it'll stop there, or maybe we didn't have the tool hanging out far enough and the tool holder crashes into something. So I usually don't spend much time watching the toolpaths move around, but so I'll speed it up. And mostly what I'm looking for is that I have this alarm that pops up saying, hey, you know, you got to crash. So next thing I do is kind of look around the part, make sure it's what I was intending. You know, and this is what I intended. I knew this was going to still be roughed out, but I wanted the whole part roughed out but the only thing that's finished is this top surface here because we had a finish pass on that facing operation. So that looks good to me. Now I want to go in. Now I want to go in and I want to finish, because our adaptive, if we go back into our adaptive toolpath, we go to the passes tab, we had the stock to leave was turned on. So we left 10 thousandths radial and 10 thousandths axial stock to leave. So now I want to go in and I want to finish the floors. I want to finish the walls. Now we have a lot of surfaces. You know, we have these surfaces to finish on the floors, and we have all these walls to finish too. So there's always a few ways to do anything. If we look at new operation 3D milling, we could use this horizontal toolpath, which is a really awesome toolpath. Actually, looking at the time, I think we have some time to just show you what that toolpath is. It's not the final toolpath I'm going to use, but we should actually just be able to hit OK. So what this will do is it'll go in and finish all your horizontal surfaces really efficiently. And that's a good toolpath. So you can see it took just a few mouse clicks and you got all these horizontal surfaces finished. We could raise up the top definition and also finish the top here. The only thing to remember with that is that the walls are not finished with a cutter compensation. So if you want to change the dimensions on this with a cutter compensation, you won't be able to do that with horizontal. So we have a really good tool in 2D milling, 2D pocket. So I'm going to select the 2D pocket, and I want to use the same half-inch tool. And I'm going to just run around and grab all these horizontal surfaces. Make sure I grabbed everything. Yeah, so I grabbed all these horizontal surfaces, and what I'm going to be able to do there is if you look at the passes tab, we have a finishing pass, and we have wear compensation turned on. So we have no stock to leave turned on. So what this is going to do is it's going to give us a floor finish and a wall finish on all those surfaces. If you look at maximum step over, we can look at the expression on that by right-clicking in that white window and look at the expression. So the tool is going to step over 45% of the tool while it's roughing or finish machining all those horizontal surfaces. Let's give that a second to calculate, and you can see pretty efficiently you can finish the floors and the walls on all those features with just a handful of mouse clicks. So it's an awesome tool. I loved when we when I found it. So I hope you guys can use that too. So the next thing I think I want to do is I want to finish the walls on this bore and probably on the profile of the part. So I'm going to right-click in the space, new operation, 2D milling, and I'm going to use a 2D contour for this. So it defaults to the same tool I've been using, which is what I want to use. I'm going to select this outside line to get the profile, and I'll select this line here to get the inner profile. So I'm going to go to my Hides tab, and I want to go 10th thou below the contour. So because we selected a contour, it defaulted to this. I could also say to the model bottom minus 10th thou, but it's in this case it's the same thing. If I go to the passes tab, my wear compensation is turned on, so we're ready to go on that. So just kind of spin it around, make sure the toolpath is what I want, and it is. So I got a finish pass around the outside and a finish pass on that bore. So I think let's do a 3D toolpath on these feet here. I think that's what we'll do next. So normally I would save it here, but let's get in. So I'm going to right click here, new operation, 3D milling. So you have a lot of toolpaths to choose from. I think what I'm going to use here is a scallop. So bear with me if we end up having to make some adjustments on this, but you'll kind of see how I would think through the operation. So the first thing I want to do is grab a ball mill. So I have this half-inch ball mill that I think will work for that. Next thing we're going to do is go to geometry selection. So I want to set a machining boundary to this area here. And if that works, then I'll go around and do it everywhere. So it's kind of an important detail. I'm going to zoom in. So when you just hover over this, it's not really the whole area that I want. So if you click on it and then click on it again, it opens up this option here. So now you can go hover over this, and I was lucky enough to where it went to where I wanted. Sometimes you do find that you have to chase it around, but there's some intelligence there. So that was easy enough. I'm just going to do it on all of them. So click here, click again, and then come up here. So click here, click again, click there, hit OK. So click here, click again, come up here and hit OK. Try it here, click again, come up and click there and hit OK. So the next thing you want to do is if you go into this avoid/touch surfaces area, I'm going to turn on touch surfaces and make that 0. Now I want to say, now come in and touch these surfaces. These are what I actually want to machine. check out our passes tab. Our step over is 8% of the tool diameter. I'll leave that for now. We can edit it later if we want to change the tool path. That's pretty much exactly what I wanted to happen right there. Cool. So we'll move on to, let's say, drill and tap these holes. I think we're doing good on time to where we'll be able to get over to the back side of this and maybe even do some blind chamfers here. So this is where I use a template. So generally I tap all my holes the same. I might have some different feeds and speeds for steel versus aluminum, but I'm going to use a template. So pretty much the only prep I did on this part was make sure I had a template for an M8 hole. So this is an M8 threaded hole. So I went in and made a template. So I'm going to show you how to use the template, and I'll kind of go back through and show you how I saved the template. So I'm going to right click in this space and create from template, and then come down to M8, and this is how I label it, but you can label it different ways. You can see here I have a 256 spot drill tap, and I put this little note in here. It's all set up to be with a 2.5 lead tap. So I didn't put that on this. I just put it in there as a spot drill and tap. So that pops up this, and that means this is going to be the spot drill, this is going to be the drill, and this will be the tap. And I'm going to create all templates. So that drops these 3 operations in there. And I'm going to right click on the first one, and I'll grab on this. I'm going to grab this conical shape, because that's going to help me define the depth, and that's kind of how I set that template up. Is it's going to take your spot drill and it's going to satisfy the major diameter of this countersink. And an important note there is if this was modeled at a 90-degree chamfer, if you use, say, a 120-degree spot drill, it's still going to take that 120-degree spot drill and satisfy the major diameter of your countersink hole there. So keep that in mind. It's a pretty neat trick if you don't have to do any math to get the right chamfer diameter. So I'm going to hit OK there. And then I'm just going to go select the geometry for these next 2. So for this, I'm going to select the wall. I'm going to make sure I have auto merge hole segments. So if you look down on the bottom of this, it's threaded to here, and then it's pre-drilled, and it also has this chamfer here. If you auto merge the hole segments, it puts them all together. So that's an important little tip. And then it was already set up to select all the same hole diameters. So we're going to hit OK there. Maybe last note is if you go to heights, I have this all set up to where it drills at the right depth. So we'll go here, select that, hit OK. So I did a lot of talking there, but using a template, you could have done that in just a matter of seconds. So I kind of walked you through how I would set each one of those up a little bit. But the important thing is once you get a group of tool operations that you're going to use repeatedly, which is very common, spot, drill, tap, you want to highlight those, right-click on them, store as template. And in this case, we already have a template in there, but let's say we made a small tweak or a small change, because we rarely get it perfect the first time. So you're going to click on that, and we're just going to overwrite this one. Hit save. It's asking if I want to replace it. I'll just say yes. So that's how you would use a template. I kind of walked you through some of the details of setting it up, and then that's how you're going to save a template as well. So we have spot, drill, tap. Let me think what else is left. I think we're ready to chamfer this part. So we're doing good on time. So I'm going to walk you through how I would do what I call a blind chamfer. So this trips a lot of people up, but it's pretty simple. So again, I do this very similarly. I do it often. I do it a similar way. So I already have a template set up, so I'll show you how to use the template, I'll show you how I set up the template, and then I'll show you how I save the template. So I'm going to right click in this space, create from template. I'm looking for my, here we go. So when I was using HSM as a customer just 5 months ago, my template list was a lot longer. So you'll find that your templates, you'll have a lot of good little nuggets in there. Once you perfect, say a blind chamfer, save it as a template and you'll be able to go back to it real quickly. So here's, it's using a 3/16 chamfer mill. It's going to be a 10th blind chamfer. What I call blind chamfer is anything like this where it's not an open, profile that goes, or a closed profile that goes all the way around something. Right here it's blind, so it kind of comes up against that wall. We want to chamfer this edge without banging into that wall. So if we right click on this and edit it, first I'll show you how easy it is, and then we'll go back and I'll show you what I did. So you just click these edges. So I'm of the belief that you pay for an expensive CNC machine, you should utilize it to do all your chamfering, and you should try to get as final of a part as you can. So you can see real quick we got all those chamfered. I'll show you how I do that and avoid these walls. So we pick the tool and we go into geometry, and this is the magic right here. It's really not magic, it's just a tangential extension distance. So if you wanted to pass up this line, you would have a positive value in there. If you want to shorten that line, you'd put a negative. It's that simple. In your passes tab, you would set up your chamfer width, and then generally on these blind chamfers, you want to use the edge closer to the outer diameter. So you want to have generally as big of a tip offset as you can afford. And then I usually get rid of the radius lead in, so I just come in at a 90. So that's kind of how I would do that. One thing to note is, if you notice, this has a tight radius, this has a broader radius. The chamfer is going to come closer to this edge if using the same tangential extension distance. It's going to come closer to this edge than this edge. So if we were trying to get in and get real fine with it, we'd want to set up two different chamfers and then have two different extension lengths. So maybe leave this one here, and then this one would be lesser. So that's the chamfers. I think we're ready to, oh, I didn't chamfer these closed contours, right? So I would do that by right-clicking, going to New Operation, 2D Milling, and 2D Contour. So if this had chamfers that were modeled into it, I'll go over that as well. So in geometry, you just select these edges here and here. Those are all the closed contours. So if you had a modeled in chamfer, you would just select the bottom edge of the chamfer. And then in the Passes tab, where it asks you for the chamfer width, you leave that at 0. If you don't have a modeled chamfer, you want to put in your chamfer width. It's nice if you have modeled chamfers because you can pick a lot of different size chamfers with one tool operation. If you want different size chamfers without them being modeled in, you need multiple tool operations. So if this was a 20 thou and this was a 10 thou, you'd want two different tool operations to satisfy that. So then we always want to give it a tip offset and hit OK. So I think we have a done part. I'm going to simulate it, or done first operation at least. So I'm going to simulate this. I'm going to right click on the setup, go to simulate, get this set up the way I want. I always make sure my stop on collision is turned on, and we should be ready to go. So I'm going to speed this up. I'm hoping those angled feet come out the way I intended it to be. If not, we'll go in and make some small adjustments.
Hey Tim, while that's simulating,
Yeah, yeah.
just a couple questions here. I don't want to throw you under the bus because
Okay.
I'm not sure if we're going to be able to answer them in the affirmative. But a couple
Okay.
questions really going around the same thing. So is there a way for us to chamfer the 3D sloped surfaces and then also that the inside of that hole that breaks through, that intersects those sloped surfaces?
Oh, that's a great question. So yeah, I've done that a lot. Usually it takes a little more fudging around. Not fudging around. Yeah, let's talk about that. So what you would want to do there is you would want to model the chamfer in, and then because really, I mean, if you think about it, this is kind of like just a chamfered foot, right? So you would treat it the same way. I'm looking for, yeah, I mean, so I use a scallop toolpath, and that's kind of why I went to this. I use a scallop toolpath for that all the time. So you would just model in your chamfer, and then maybe have a small, and do the same exact selection. So you would want to do scallop, do a machining boundary of just the chamfer, and then pick your touch surface as just the chamfer. So actually, I have an example. If you want to, we can jump over to that real quick. I might fumble around a little bit looking for it, but
yeah, that works.
yeah.
And while you're looking for that sample, so basically what you're saying
Yeah.
is you're just going to do a 3D toolpath of, so you need to do a little bit of work in the model to get the surface, the chamfer surface that you want, and then you just apply a standard 3D toolpath to it.
Exactly, exactly. Just got to remember where I put it. Here we go. So we're doing this part for one of our partners, and we didn't want to put a chamfer mill in the machine, but then we also wanted to chamfer these little 3D edges, right? And then we also wanted to do what you would normally think of as a chamfer mill operation. We didn't want to put a chamfer mill in the machine, so we chamfered all these edges around here, but also these 3D chamfers. And then we also did these blind chamfers here, but because we modeled it, it was super simple. And we actually also did the chamfer here, so I'll kind of walk through that. This chamfer right here, again, I used a scallop toolpath. In the geometry selection, I did exactly what we did on that foot. I selected here and here, and then chose those as the touch surfaces. This is probably a pretty good example of what you were talking about. We modeled the chamfer in, and let's find that here. Okay. And then this took, really the work on this was finding the tool that would fit, make that geometry. So it took me a couple minutes of working through it, but in the end it was really just finding the tool that would do it. So if we open that and look at it, the geometry I selected was the same way. I just clicked, double-clicked, and then chased that geometry around to be all these points here, and it came out pretty nice. So does that answer that question?
Yeah, yep, I think it does.
Yeah, I'm kind of avoiding doing it here because you're going to end up watching me look around for a tool in my library somewhere that would chase that chamfer around, and we might have some issues modeling up a chamfer in here. But it's my last job, I did that all the time. We 3D machine these feet all the time. I would put a little chamfer here, and we run a little ball mill around there in the scallop toolpath. So,
all right. Tim, do you still have the other file? Yeah, another one just came in asking if you can simulate, and I think that was based on the other file. I don't know if you still have that open. Yeah, could you just run a simulation?
File here. Yeah, of course. This was actually getting made out of a big plate. You want to see it actually moving around, or you just want to see the final?
I think we just wanted to see.
So this is what the final results are.
Yeah, beautiful.
Yeah, so the nice thing about these blind chamfers is if we went in there and looked at, let me find it, if we look at this on the geometry tab, I clicked avoid surfaces, so I clicked, I avoided this surface here, so the tool went up, 2 thou, away from that wall. So if we could make that closer, basically based on our comfort level of how close we wanted the tool to come to that wall. So it's kind of a good way to do a blind chamfer without having to do that tangential extension in a negative direction. And we're working on some other cool stuff too that I'll keep an eye out for as far as blind chamfers go. So we're ready for a second operation?
Yep.
I don't remember. Yeah, so I simulated this already. So the way I would move over to a second operation on this is, we could definitely do a new setup. I think I would do, this is kind of my default behavior, is I would start here. I would just highlight that and hit Control D for duplicate. If you forget these keyboard shortcuts, just right-click. They're all listed in the right-click menu. So I duplicated the whole job, which might not sound like it makes a ton of sense right now, but I think hopefully it'll make sense here in a second. So I'll turn the part over, and I think the way I'm going to hold on to this is I want my XYZ, my data, or my work coordinate system to be set up in the center of the part, but I want it to be on this surface here. So like I'm going to set that on a parallel surface. So now I'm just going to make some edits instead of having to go back through and change a bunch of stuff. So now I don't have to select the model. On my Z selection here, I can pick this surface to snap it up to that Z, and then I can change this origin to go to model box point. So that kind of snaps these points to a box around the model, and then I can click on that bottom center point right there. That's exactly where I wanted my work coordinate system. So we'll go over to stock, and the only thing I have to do on stock is, remember we had 100 thousandths going in the negative direction before. I just need to turn that to positive, so it's exactly how it was before. And then this is where I would change this to a different part number, and I'm going to call this, second op. I maybe call this G55, so call that number 2. So now you'll see everything turned red because something changed and it needs to be regenerated. Well, realistically, all I want from this, what we did before was this last chamfer. I want to reuse it for these chamfers and the face mill operation. So I'm going to highlight all these and delete them. Okay. We shouldn't have to do anything other than reiterate the facing operation. So we got the toolpath we wanted for that. And then for the chamfers, we do have to reselect the geometry. So we're just going to X out of the pre-selected geometry and then just grab this, these holes, and this bore. Then lock, that gives us our whole second operation should be done. Yeah. So this is where I would control select both operations and go simulate. So again, I have stop on collisions turned on. I'm going to hit play, speed it up, make sure it looks like how we want it to look. So that's the part right there. Any questions now?
Okay, let's see what we have going on here. Okay, everybody, well, now's your chance. I think we've gotten through that part pretty well. Let's see if we have some questions. So I have a question coming in from Paula, machine soft jaws for the flip. So, I guess that's a question. Would you machine soft jaws for this part, or place it on parallels? What do you think there?
Yeah, there's different ways to do it. I would personally probably just grab this in hard jaws and stop up against that stop there. Yeah, I think that would be a good way to do that, is just put that against the stop and then run some hard jaws against these surfaces.
Yeah, I think we lost your mic there, Tim. It's suddenly gone really quiet. There we go.
How about that?
That's better.
I took a drink of water and I forgot to move it back. Sorry. Yeah, so honestly for this part I would just put it against hard jaws on these surfaces.
Right.
We're only removing 100 thousandths of material. We should probably do another webinar that kind of walks through setting up soft jaws on a contoured surface.
Yeah, it's a good idea, and when you've got good CAD like this, parametric CAD, you can use the model to create soft jaws or pockets in fixtures. So I'm going to take a note on that. That's a really good topic for a webinar in the future. So we'll do that. Okay. Let's see. So I've got Michael is asking, or says runtime. So I think what he's referring to there is getting your cycle time when you're in the simulation mode.
Yeah, so that's a great question. So let me actually, I started doing it before I started talking. So I would click both setups and I would simulate them so I have a full runtime, and then I would go to statistics. Sorry, I would go to statistics. So on this part we're looking at 23 minutes and 6 seconds.
Okay.
Now the other disclosure on that is I didn't look at any feeds and speeds on those tools. I just grabbed a bunch of tools.
Okay, so obviously the speeds and feeds will factor into that machine time calculation. So as long as you've got accurate speeds and feeds in your toolpaths, it will represent what you'll get on your machine, or pretty close to it. It's not going to simulate tool change time because it's not going to know your particular machine, but as far as machining cycle time, that's going to be pretty close. Let's see, we've got a question from Dustin. Is there a stock leftover view, stock that the tool didn't cut? Thinking that might be like pieces of stock that are basically not turned into chips, solid pieces that are going to drop off, something like that. I think we may have lost your mic, Tim. Are you still there?
Hey Derek, can you hear me?
Yeah, I think your mic just popped in. Got a lot of background noise though.
How about that?
That's better.
I'm sorry. I don't know what happened.
Were you able to hear me there?
I was. I heard the questions. Yeah, I haven't had to deal with that. So if we could maybe get some follow-up, we'll follow up on that. So was the question that we're looking for the basically drop-off type stuff that wasn't turned into chips?
I think so. So maybe Dustin, if you can follow up. Oh, hang on. Let's see. I see Dustin's got a follow-up here. So if you use a bigger tool than the corner.
Oh, okay. So like a stock compare, right?
Okay, maybe that's what we're saying. Yeah, so stock compare. Let's take a look at stock compare because it's a great feature. And then Dustin just typed in yes, that's what he was talking about.
I might have to fudge something. So let's run through this and then we'll do a stock compare. I use it all the time on our HSM works, and I have to say I might not have used it here yet. So this is a good example. So so these little blue areas are areas that essentially have a little bit of material left in them. So as I was saying before, I didn't do a lot of prep on this. I would have to go back and see what the issue is, right? So
Well, Mike and I did some work on this recently, Tim, so I wouldn't
Yeah,
start playing with the numbers yet, but you see those two numbers,
yeah.
we need to do a little bit of experimentation, but those are basically tolerances, so you can edit those, and I
Ah,
haven't come up with the exact correct combination yet, but that's basically
okay.
the tolerance of your model, and then showing a compare. So it starts off kind of loose so that the processing time is quick, but you can
It's
tighten it up.
faster.
hmm
Gotcha.
And you can
Okay.
see, the chamfers, it's actually seeing that as a gouge right now because those chamfers were not modeled on the
We're
model.
not modeled in. Yeah. Yeah.
And then vertical walls are always a little bit tricky in compare. So you've got to get just the right combination there to get your compare just right. I mean, right now, when you're seeing a little bit of light blue, that's telling me that's just in the tolerance zone. That there's no real error
Yeah.
there. The dark
Yeah.
blue, obviously, is where material has been left. So, yeah, that's your compare. It
My
works well.
my thought on that real quick, just kind of talking it through, is that we also have, that's probably considering this here. So on those finish passes, our default tolerance was 4/10,000ths of an inch, and I'm feeling like if we change that to 2/1000ths, made it bigger, I'm willing to bet that those I'll have to play with that more. I haven't spent a ton of time on it. What I was going to say is I would be almost willing to bet that those would get darker because um, it's possible amount of you know what I'm saying.
Yeah, well, any 3D toolpath actually has a scallop height to it, right? It's just a question of
Yeah, exactly.
how close you tune it in. But
Yeah,
yeah, so that was good. Let's see
perfect.
now. Got some other questions here. Let's see. Oh no, actually, looks like we got through them all. So if you guys have any other questions, as soon as we get close to 1 o'clock, it always people start dropping off and getting back to work. So now's your chance here, guys. We'll hang on another minute or two. Let's see. So question from Paula: can you redo the feet in a way that the angle of end mill can be related to an edge? An angled edge. Are you talking about, Paula, there, if you would set the part up at an angle and then just come down and cut those with a flat end mill? No, change the machining angle. Let me read that again. I'm not sure that I understand the question yet, but I'll read it out in case you hear something that I don't there, Tim. So can you
Yeah.
redo the feet in a way that the angle of the end mill can be related to an edge, angled edge? Change the machining angle for aesthetics. And yeah, a couple other people are saying, I think he means multi-axis machining. I think he means more of a planar path. So I think what we're talking about there, Tim, is setting the part at an angle so that either the side or the bottom of an end mill can just come and skim that face.
Oh yeah, yeah, yeah. So that would be just another job setup. Talking like to side mill these feet.
Mm-hmm.
Yeah. So I just copied that job, and we'll do a kind of quick and dirty. First thing I'm going to do is I want to, yeah, so our radius for this is 275, so I should be able to take that same half-inch tool and run it through there. Go do another setup. I'm going to do relative box size and no additional stock, so I'm just going to make a material just big enough to get around there, and we'll call that point there. We'll call our XYZ0. So hit OK. Get rid of both of those. So then we need to make sure this is our default folder. So I could hit Shift D or So that's our folder that we're working in now. And then let's do a new 2D milling 2D contour. We'll grab that 1/2" tool. Go to geometry selection. And then I'll pick this, I'll pick it again, and I'm going to select an open contour. So I'll pick these here. Okay. I'm going to deselect that. Actually, I'm going to hit no, I don't want that. So hit OK. And then the heights, you just set your height at, let's say it's just a selection to be this deep, and should be able to hit OK. Is that what we were talking about? And I'll run through that. So the issue there, not the issue, but that adds 2 more operations. So you're going to have to do it there and then flip it over and do it there.
Right. Yeah. So I think that answers that. Let's see. Got a couple more questions here. Can you send out a CAD neutral file so that you could load the CAM into, say, NC Vericut software? Do you provide the interface software file?
We're actually working with CG Tech right now. So I guess the quick answer to the Vericut question is we're working with them right now, and I think pretty soon we'll have something. I was just met with them on Monday and Tuesday, and we want to start partnering up. Right now we can post out to Camfleet. So it's just, we treat it like a post. You just go into post, and your post processor would be Camfleet.
Right.
I really don't know my alphabet. So then and then it dumps out the part, the tools, everything it needs to be in the third-party verification.
All right. It sounds like we've got that coming for Vericut very soon. Also a question from Bob, do you support wheel cutters and undercut milling with a wheel cutter?
Maybe I'm not clear on what a wheel cutter is. Is that like a slitting saw or something like that?
Key seat cutter?
Yeah, key seat or slitting saw.
Slitting saw, yeah, sure.
Yeah, so the 2 toolpaths that we support that with right now is it's going to be the horizontal. So if you say this surface here had an undercutting, you could use horizontal, and it'll make constant, it'll make a step overs, and then it'll go under and then come out and retract. And then 3D contour is the other one. So you can do some lollipop cutting and things like that, and also key seat cutter or slitting saw you can do with 3D contour.
Right.
As far as adaptive goes, it's something our development team's working on, to be able to do an adaptive cut with a key seat cutter. It'll do it now. It just has a habit of retracting while it's still under something. So
right.
I've had to in the past just write a little G-code line there that just moves it out from under the slot and then retracts first.
Right, and of course you could always drive a key seat cutter along any 2D geometry.
Exactly, yeah. So that's the easy one. You can definitely just do a 2D contour, and it'll do that easily. Yeah.
Right. Bob's asking, can you execute a contour with the slitting kind of like flowline in Mastercam? Can you execute a contour with the slitting kind of like flowline in Mastercam?
Something like this, or
I wonder if that was the 3D contour that you were talking about.
Yeah, so our 3D contour tool supports undercutting with like a lollipop cutter. It's probably where I would see it most, with a slitting saw or something like that. I haven't done it, so I don't want to sign up for it if I haven't done it, but we can definitely do some undercutting with a lollipop with our 3D contour.
Sure, and then Bob, just send us a file if you want us to take a look at that, and we'll take a look at your specific request there. And I'll just type in my email address into the chat here for anyone who wants to send me a file or any other kind of correspondence. So look down in your chat box. It's Derek at p9cam.com. Okay, there we go. Let's see. Almost done there. So Bob says okay, he's got that. And then question is, when is Flow being implemented in Inventor? I'm not sure. Do we have a date on that, or any good info on that yet, Tim?
Well, I hate to sound like a lawyer, but as a public company, I think they're hesitant to throw out a lot of dates on things for some legal reasons. But one of the things I'll show you now, we're working on it. I've played with it. I'm trying to see if it's in beta mode. So if anybody wants to play with features that are kind of being worked on in the background, if you go into this gray space and hold Shift and Control and then right-click, you can come down here and turn on beta mode or turn it off. Beta mode stuff we're testing, stuff we're letting other people test. It's a lot of it's working toolpaths, but you need to definitely use the beta tools with caution. So the reason I did that is I wanted to see if it's in yet. So I went to 3D. I don't see Flow yet, but it's definitely something that's being worked on. The reason it's not like what we have in HSM Works is that they've been improving what was in HSM Works. I think people are going to be a lot happier with it. Not happier, but they're going to be super happy with it. We have a more flow and some other cool stuff, and that's kind of the foundation for a lot of what's going to drive our or pretty much any 5-axis toolpath.
Okay, so not quite there yet, but it's one of the top priorities of our development team, and it's coming very soon.
Yeah.
All right, guys. Well, we're coming up against 1 p.m. here on the West Coast, so I think we'll close it down for today. Thanks, Tim. Fantastic presentation. And for everybody out there, we will be processing the video, and then you'll receive an email. It usually comes out in about 24 hours, and I'll make sure that the link to this video is in there. So thanks again, Tim, for a fantastic presentation. Thank you, everybody out there, for investing time with us. We do appreciate it. And everybody, have a great weekend.